Hey there guys, Paul here from theengineeringmindset.com. In this video, we're going to be looking at the difference between the hot, neutral and ground wires, as well as the function of each with some worked examples. This video is for homes in North America. If you are outside this region, then you can still follow along, but your system will work and look a bit different, so do check out our other videos. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Before we get into this video, there are 3 things I need you to remember. Number 1, electricity will only flow in a complete circuit. If you come into contact with an electrical conductor, your body might complete the circuit. Number 2 is that electricity always tries to return to its source. And number 3, electricity will take all available paths to complete a circuit, but it will take preference to a path with less resistance, and so more current is going to flow in that path. Okay, so we're going to be looking at the hot, neutral and ground wires for a typical North American residential electrical circuit. First, we'll see a really simple circuit to understand how it works. Then we're going to apply this knowledge to a complex residential installation. When we look at a simple electrical circuit with just a battery and a lamp, we know that to turn the lamp on, we need to connect both ends of the wires to the terminals of the battery. Once we connect these wires, the circuit is now complete and electrons can flow from the negative through the lamp and then back to the positive terminal. So for the circuit to be complete, we need a wire to carry the electrons from the power supply and over to the light. This wire is our hot wire. Then we need to connect another wire from the lamp and back to the battery for the electrons to get back to their power supply or from their source. Now this wire is our neutral wire. The hot wire carries electricity from the power supply and it will take this over to the load. The neutral wire carries the used electricity back to the power supply. If we look at a residential electrical system in North America, then we will find 2 hot wires, a neutral wire and some ground wires. If you want to see in detail how this all works, then check out our video for that, links in the video description below. Now imagine for a second that the home's electrical system is connected to a battery, and we have just 1 hot wire and a neutral wire. As we saw with a simple circuit, for the light to turn on, we need a hot wire to supply the current to the load, and we need a neutral wire to return the current to the source. Electricity therefore flows through the hot, through the bus bar and the circuit breaker and into the light. It then travels back through the neutral and over to its electrical source. Now of course, homes are not connected to batteries, they are connected to transformers. So we're going to replace the battery with a transformer, and there we go, we have a complete circuit. The electricity in this circuit is AC alternating current, which is different from the DC direct current which we saw with the battery. With DC, the electrons flow directly from A to B in only one direction, much like the flow of water down a river.